Alright, welcome back everyone. Today we're going to try to solve another coding problem under 40 minutes or so, hopefully. This stream is for entertainment purposes only. I'm just checking that everything works fine. And without further ado, let's see what the problem we've got today. So, pick one. Okay, it's a medium. Largest divisible subset. Given a set of distinct positive integers, alright, so they're positive, return the largest subset such that every pair of elements in this subset satisfies so the remainder is 0. So y2 divided by 4, I mean the modulo 4 is not 2, is 0. I don't understand. Such that every pair I see. So either one way or another one is can be divided by the way. Okay. Uh-huh. So we have the length of these numbers is 1000. And to me it sounds like quadratic algorithm. Really, you just create the what? Alright, does it imply that if, okay, so let's say we have 1, right? So obviously 1 can fit in any set, but it doesn't mean that if 1 and 3 are in the set, then we can fit there 4 as well. It doesn't work this way. So there's no such thing as if we already have element in the subset, we can safely add and compare against this element. So let's see, we may create uh, the Boolean, or let's say vector of vectors of Booleans, right? And basically it will tell us if I and j can be within a set or not, right? So let's switch to the whiteboard. So I think that, oh, a lot of mess here, that having something like, let's say in this case, 1, 2, 3, and 1, 2, 3, we say, okay, 1 with 1, obviously, if we divide the number by itself, it's okay. So yes, 1 and 2, yes, 1 and 3, yes, then 1 and 2, yes, 1 and 3, yes, no, 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 right? Once we have this, it's now sort of clear that we can, let's say, have this number and this number, right? Then for 2, we check if anything here is matches as well. Or let's say something like this, right? So we don't count the same number. So now all right, so but does this map help us? That's the question. In any way. So this matrix basically will tell us, let's say I have these okay, the examples are not very great, but let's say we have 1, 2, 3, and 8, and here we have 1, 2, 3, and 8. So 1 can be with 2, with 3, with 8, same here, right? So 2 can be with 8 but not with 3, and here, right? The same thing, not with 3, with 8. And 8 is okay to be with 1 and 2 but not with 3. So so now, having this matrix, how we can say that, okay, if for, let's say 1, we have either this choice, or this choice, right? Let's say if we have 2, then we should go this way to check if it's compatible with either this or that. Is it like that for search? Like trying to find the path. And let's say 1 to 2, 2 to whatever, 8. Yeah, looks like a Bradford search. But then how we can make sure that this yields the longest pass? Or can it be something simpler, that we start once we have this matrix? Then we just say, okay, 1 is okay with 2, 3, and 8. 2 is okay with 1 and 8. 8 is okay with 1 and 2. Alright? And once we have it, yeah, it's like it's hard to find the quadratic algorithm here. So the cubic one is obvious. Alright, let me implement the dumb solution. I give up. Sorry, medium problem today. I'm not gonna solve it. So let's have vector of vector, right? And let's call it subsets. And so let's first create the first cycle. We basically need int I, int nums, and 4. Int j, int nums, right? If I equals j, continue. Actually, we don't need even to do this. Okay, let's start like this. I less than nums size minus 1, right? I plus plus j starts from I plus 1 j less than num size now, so to the last element j plus plus. So obviously it will never be equal here. So what do we say? All right. It's not vector. It's an ordered set, right? So if I percent j, no. If nums I percent nums j equals 0 or vice versa, all right? Ji equals 0, then what we say? We say that unordered set, let's call it pair or P, another set of integers equals to ij, right? And then we just insert two subsets, push back these ij, this p, right? So this is n square by half number of sets. And then we're going to have quadratic in the sense that now for every integer we'll go through all elements there. So it's actually even worse than quadratic. Oh my goodness. Dang it. So now all we need is to say in nums, right? But this is very trivial algorithm. If, and then we go for subset auto subset in subsets, if subset count num then continue, otherwise so it's even, oh my gosh, now it won't pass the time complexity, that's for sure. Otherwise we go what? Otherwise we say can add bool, can add false by default, right? Oh, let's say true. And then we go for int num1 in subset. Basically we do this, right? If this not equal 0 and this not equal 0, so num1 and num1 num, we say can add false and break, right? And then if we can add, so if can add, we say subset insert what, num, right? And finally we should say int max size equals 0, or let's say, yeah, let's say 0, and then let's have something like int max index, right? You can have 0, doesn't matter. So 4 outer subset in subsets, and you can use const. We say what? We say if max size is less than subset size, then max size equals to the size of the subset. And okay, so let's make it then int to 0, I less than subset size, and I plus plus, right? Then max I equals I subsets I size, and then finally we return subsets max I. Now, do we really need to go through the pairs here? I don't think we need to, because all we can say is this, right? So we create subset with one element, which is basically the num. So we know the size initially, right? And so we can allocate it initially directly nums num size, right, and then we need it as unordered set. Think like this. And then all we need to say is basically subsets I, Jesus, insert, and actually here's the mistake, it should be nums I, right? Once we have this, then we have this one. So we go for every number in nums because it's distinct. We check, okay, subset and subsets. If we already have num, we continue in this subset, meaning we've checked that, right? And then for every number in the subset, we check that we can add the new one. So it's two ways check. So if we can add the new element, it means that we match with all other elements. And as a result, it means that all other elements also can match with that element, right? And then we can add, insert num, and then we just select the maximum size among the subset, which is the size of the number of elements. So here is so it's cubical complexity, yes. So it will work, but most likely won't pass the complexity check. But I'm too lazy to think of anything else. I see. Okay, so we can have it vector int, right, called result, which is subset max e begin, and max e and return this result. Yeah, obviously it will work. Now the question is how scalable it is. My understanding, it's not like scalable sufficiently to pass the check. But because it's too late, I'm okay with whatever number of tests we pass. Oh, wrong answer. Interesting. So if at least one of these equals 0, num and num1, and vice versa, num1 and num, then you should be fine. Interesting. Let me check. List I equals to list I, right? or not the subset. So then we have, let's say, this. It's not subset in subsets, it's like num in subset, right? And this will be subsets I. So we say num cout num1, right? And we separate it. Let's say here we say cout and the line. Just to check what subsets we have as a result when we select the maximum one. Interesting. We don't have subsets that have 3 in it, which is super weird. Because at the beginning we should have it. Alright, yes. They have subset 0, 2 and 1, 1 and 2, 1 and 3. Right, makes sense. Okay, so let me check if it now works with this fix. Obviously it won't pass time complexity check, but no, it still doesn't. Let's then check what's missing here. One 90, 90, 540 and 5. Alright, obviously. Then we have these 89, 54. 54 can be divided by 18, I guess, right? That's 3. By 9, it's 6. 2 in this one, okay, makes sense. But where is 360 and 720, I wonder? Because it's 5. Interesting. So it doesn't describe all of the possible combinations, right? So this part doesn't works, right? So which means it really should be that big of a deal. So we really should have, oh man, all pairs to capture all possible solutions. That's what we're missing. So G equals N plus 1. And then we say if nums I percent nums j equals 0 or vice versa, di we say unordered set int of whatever p, the pair or the subset, let's call it subset, equals to this pair, right? So the problem if we add 5, then we cannot add, let's say 18, right? So maybe this thing is wrong. Alright, so it really sounds like we need to do that for search here. But we're already running out of time, so it's not like it's okay if it should be just subset pushback. Nice. What? Seriously? Oh man. So in this case it's 43 out of 48. So at least we can take this one. This one fails. It's a good. Oh man. Like how we can bind to a null pointer? Okay, I give up. I don't care. Let's use this version. 43 out of 48 tests. It's probably we can do something that research or whatever. And we will see right what was the stupid simple solution for this problem. You know, I'm so stupid that I can't even think of this simple solution here. Man, it's a mess. So 43 out of 48, 0 times 0 space because I had no idea. Alright, let's switch back to the main scene and see what was the simple solution here. I mean, just simple Java solution. It's dynamic programming. That's why every time you think it's something stupid and unclear, it's dynamic programming. Find LIS where current element is divisible by previous element. First step is to sort the array and log n. Interesting. Since num is sorted, if the num equals 0, I greater than j, then the list is updated. Alright, so we sorted the num. Answer. Is it always yields the largest one? I just wonder if we start with the smallest one. Okay, so I equal 1, j equals 0. I equal 1, j equals 0 equals 0. Then we say this I, which is the vector of int, is max between current list I and 1 plus list j. Oh man, too much. Okay, it's dynamic programming, so it's simple. If you spend 2 hours understanding this simple structure, the way how you reuse this simple structure to solve it, and then once you have it, then oh yeah, it was obvious actually. I don't even know LIS. What is LIS? Let's Google this. Dynamic programming LIS. What the heck is this? Longest increasing subsequence. Yeah, alright. So these, dynamic dudes know a lot. They use dynamic programming for various stuff. Alright, so I think that's it for today. Thanks everyone, and see you next time.